Hi students, welcome back to this course. An Introduction to Mechanical Engineering. I am Professor Yao. Case Study 2. Electrical Power Generation. Electrical Power Generation Plant. The keywords. Electrical power generation plant. Turbines and generators, high pressure and high pressure steam, a high temperature and high pressure steam, the kilowatt hour, fossil fuel power, nuclear power, hydroelectric power, natural gas power, and the renewable energy power, cooling towers, thermal pollution, primary loop and secondary loop, steam generator, turbine, electric generator, condenser, and a pump. To condense, Rankine cycle. Electrical power generation plant. The vast majority of electrical energy that is used in the United States is produced by power plant that employ an energy cycle based on driving the turbines and the generators using high temperature and high pressure steam. The energy unit, known as kilowatt hour, which is the product of dimensions for power and time, is the amount of energy that is produced during 1 hour by a 1 kilowatt source of power. Various contributing sources of electrical power include fossil fuel power, nuclear power, hydroelectric power, natural gas power, and then renewable energy power. Power plants are often located near large bodies of water, or they employ cooling towers in order to disperse the wasted heat. Thermal pollution. This byproduct is sometimes called thermal pollution, and it can disturb the habit of wildlife and the growth of vegetation. As shown in Figure 7.20, the cycle for fossil fuel power plant comprises 2 loops, primary loops and secondary loop. Primary loop. The primary loop comprises the steam generator, turbine, electric generator, condenser, and a pump. Water circulates in that closed loop, and it is continuously cycled between liquid and steam. Secondary loop. The purpose of this secondary loop is to condense the low pressure steam in the primary loop back into liquid water after it exits the turbine. Cold water is drawn from a lake, river, or ocean, and it is pumped through a bank of many tubes. It is important to note that the waste that circulates in the primary loop is entirely separate from the cooling water in the secondary loop, and no mixing occurs between the 2 loops. Rankine cycle. continuous converting water between liquid and steam. The power plant operates on a cycle named Rankine cycle. Water and steam are used to physically move energy from one location in the power plant, for instance, from the steam generator to another, the turbines. The energy cycle in the electric power plant. The key words: pump, the steam generator, to drive the pump, a network of tubes at high temperature and high pressure, a water wheel, condenser, low pressure and low temperature waste. Water is more easily pumped and then steamed. It's fed into the steam generators. The energy cycle in an electric power plant. Pump. Beginning our description of the power plant. At its pump, liquid water is pressurized and pumped into the steam generator. Mechanical work, which we label as W sub P, is drawn from the power plant in order to drive the pump. Steam generators. As fuel is burned, the combustion gases hit a network of tubes in steam generator, and the water in the primary loops turns into steam, and it is pumped through those tubes. In a steam generator, the quantity of heat Q sub Sg is transferred to the water in the primary loop in order to create steam at high temperature and a high pressure. The steam then flows to the turbine and performs mechanical work by causing the turbine's shaft to rotate. Turbine. Each stage of turbine is analogous to a water wheel, and a jet of high pressure steam strikes the blades in the turbine. Each shaft is forced to rotate. The turbine is connected to a generator that ultimately produces electricity that leaves the power plant. The turbine's work out is denoted by W sub T. Condenser. The spent low pressure steam leaves the turbine and next enters the condenser, where the quantity of waste heat Q sub C is removed from it and then released into the environment. The steam is condensed to a low pressure and a low temperature water so that it can be pumped and recirculated through the system. Water is more easily pumped than steam. The cycle repeats as the water exits the pump and is fed into the steam generator. Since the pump is normally driven by drawing power from the turbines, the plant's net output is W sub T minus W sub P, with the adage that the real efficiency is the ratio of what you get to what you pay. The efficiency is measured by the power plants and the net output and the amount of the heat that was supplied. The nuclear power plant. The keywords: the nuclear power plant, the reactor, fuel rod, the principle of nuclear fusion, the nucleus of an atom, the layout of a nuclear power plant, reactor's core. For safety reasons, it hardened containment wall. Solar power, photovoltaic, solar cells, integrated circuit, computer microprocessor. The nuclear power plant. In a nuclear power plant, the reactor functions as the heat source, and the fuel rod comprised of radioactive material replace the fossil fuel of coal, oil, or natural gas. The reactor operates the principle of nuclear fission, by which the structure of the matter is altered at the atomic level. The energy is released in large quantity as the nucleus of an atom is split. The fuels consumed in this manner store an enormous amount of energy per unit mass. Just 1 gram of uranium isotope U-235 is capable of releasing the same amount of heat as some 3,000 kilograms of coal. The layout of the nuclear power plant is shown in figure 7.21. It differs from the fossil fuel plant in that there are 2 distinct internal loops. Water flowing in the pump in the primary loop into direct with the reactor's core, and its purpose is to transfer heat from the reactor to the steam generator. For safety reasons, the primary loop and the water within it do not pass outside hardened containment wall. The steam generators functions as a means to transfer heat from the water in the primary loop to the water in the secondary loop. In short, it keeps the 2 loops entirely isolated from one to another. The steam in the secondary loop drives the turbines and electrical generators in the same manner as in conventional fossil fuel cycle. At the outmost level, the tertiary loop draw water from cooling for cooling purpose from lake, river, or ocean, and pass it through the condenser. In that manner, the low pressure steam leaving the turbines is condensed back to liquid water so that it can be performed back to the steam generators. The power supplies within the 3 loops do not mix, but heat is exhausted between them by the steam generator and the condenser. solar power. The photovoltaic literally means light electricity. Solar cells are one technology available for converting solar energy into electricity. Solar cells are made from materials that absorb photons of light and release electrons, namely the direct conversion of light into electricity. At the atomic level, photovoltaic cells are relatively expensive because they are made from processed silicon, just like integrated circuits and the computer microprocessor. Homework: handwriting out keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.